Hey everyone, Central. Quick on the draw, congrats on the first. You're right, that's my bad. I'm telling you what to do. 10 streak, thank you. Okay, we're good. Okay, so I'm gonna start the stream talking about the problem that's on the screen right now. Someone DM'd me, asked me about it, and normally I don't like doing math help in DMs just to people who like message me out of the blue, but this one seemed interesting enough and they seem like a nice person, so. Hey Rapture, how's it going? The question was pretty open-ended. They kind of had this idea for a shape and want to figure out its area. And so I'm going to attach some assumptions on it and solve that, and maybe we can mix up what the assumptions are. So I'm doing good too. Thanks for asking. Maybe I want to type. I don't know what the right, would it be sub tens or something? I'm gonna say spans. An angle, ugh. Wait, is that not the, what is that thing for math symbols? Maybe Enigmabot is asleep. Do I have a command for it? Oh, you have returned. It's been so long since I've been able to say your name. Welcome back. I'm mispronouncing every single letter in your name. I hope you've been well. Where am I going with this? Okay. Because if we are given these conditions in scenario one, I think there's kind of a neat trick we can do here. Oh, I don't have one for help. If you have a question, let me know. A project I keep saying I want to do and I continuously like not do it is I want to make a queue system where a command like exclamation point help would actually do something, but it's a little bit of a big project, so it's more of a dream right now. I've already done that exo by myself one time. I was bored. Oh, like for this sort of thing? Yeah, this the person who asked this just said they kind of like came up with a problem themselves one day and weren't sure how to solve it. And so if we're given the things that I wrote down, I think there's a pretty slick way of doing it. The area of a sector is pi theta over 360 degrees, I want to say. Oh, pi r squared theta over 360, it should be, right? Does that make sense? I don't know. I should Google this. Let's not get this part wrong. Yeah. Okay, the circle angle the quadrilateral made between the edges and the radius is induced subtraction. Yeah, Jed. The person who asked the question mentioned what grade are they in? 9th grade. So I'm avoiding radians because I don't know if they know what radians are yet. But yeah, the formulas are a lot simpler in radians. What am I doing again? Yes, what I was going to do is yeah, exactly. That's the idea, Jed. I guess I'm using a lot of colors here, but this is I don't know if I'm over explaining this right now, but we'll roll with it. Ooh, oh, we do know. Okay, we know the angle here. That's what saves this. And so we know by, they might not know trig, but this isn't possible without trig, I don't think. We know that length right there should be r sine theta over 2. And then I guess the height is r cosine theta over 2. This feels a little bit lame. Ugh. Oh, I'm bringing that little dash with me, apparently. There we go. No, this is terrible. Ugh. There, like that. 1/2 r squared sine theta over 2 cosine theta over 2. And I think we have a little trig identity there to make it just r sine theta. Am I using that identity in the right direction? Oh wait, no, there's a 2 involved in that identity. The identity I'm trying to use is sine 2 theta equals 2 sine theta cosine theta. And I forgot to put the 2 in front, right? So it should be a quarter? A quarter. That part is really important, but This is a little bit neater. Um, hey, Rapture. um, okay. Let's go back to text now. As in, take the curve of the sector and flip it. Okay, so let's go back to blue. Well, no. Let's almost make like a math equation, I guess. Well, There's probably a better way to explain this. This is what's coming to mind, at least. Yeah, what's up, Jed? Hey, Mangoes. Okay. Do the concave triangle and the sector together form a parallelogram? Oh my god, I think we have to do some assumptions. It's going good, Mangoes. How's it going for you? I'm sort of this question that I got DM'd on Discord, and in a way, I don't take questions that are just like DM'd to me out of the blue, but this one seemed kind of fun to think about. So, yeah, because like this triangle is drawn nicely, but you could have like a scaling triangle or something. Oh, maybe that's what was saying before, looking at the quadrilateral that is created. There probably is something there, but it's not going to be as clean if couldn't it be scaling? Are you telling me that? Oh, and in the magical scenario 1 land that I created, yeah. So I'm sorry. Their question, their original question was very like open ended. I myself put this assumption here for scenario 1. So like this was just like the first draft, or I guess like the first stab at it, where we make it assumptions to make it a simpler problem. But yeah, for this scenario, I don't know how you would show it, but I do feel like this angle theta should also be this angle up here. That's for being, yeah. You should have thought about that before, like, you know, not having my stream, my offline page open 24/7 for the exact second that I start. Yeah, so you're right. I did explain when I very first started the stream, but yeah, for Brandon who's just hopping in, I'm working on this very open-ended question that I summarize up here, and then the scenario 1 is something that I just created to make it a little bit simpler to think about. The vectors are haunting you, Thunder? Oh no. If you have a question, let me know. You do? Okay. I'm gonna finish my thought on this one, and then I'll take a look. It's on scenario 1. I think we'll do scenario 2 after. Where I think we can remove the assumption that it's isosceles and still get a result, I think. If we remove the assumption that the curve is a part of a circle, then I think we get into calculus. That I'd rather not do for a 9th grader. Or, I mean, it'd be tedious, so I'd rather not do it in general. Hey, Zach. Hey, Pen. Hope you two are doing well. I looked a little bit on both your streams. Hey, Rex. The party's all here. If triangle isosceles, you bisect the top angle. So any attached circle should be on that bisector. That feels right to me, Jed. Yeah. So yeah, for all you who are just tuning in, I got sent this question here. Or I'm sorry, I got some like, this is the original question, like very open ended, and I have started to think about it just in terms of like I'm putting my own assumptions onto it just to get my head around it. So in scenario 1, I'm taking the triangle to be isosceles, and this curve to be a part of a circle. The person who asked me the question they said they're in 9th grade, so I'm trying not to get into. I did have to use some trig, but even that I feel a little bit bad about. Is the inner vertex centered? Oh yeah, hey Cold Gold. Do you mean like, wait, the inner vertex? Oh, like that vertex up there? Not necessarily. In the picture they drew it, I think they kind of drew a nice scenario. But I'm kind of taking the question as like in the scenario 1 that I made, it is centered. I think we can still work it out if it's not centered though. That's kind of like my idea for the scenario 2. But the idea is if the kind of triangle is isosceles, and isosceles here just means like the two straight sides are equal, and the curve is a circle, you basically can just look at the sector of the circle and subtract out that cap twice. That's the idea for this kind of nice scenario. And then we can make it less nice in scenario 2. But yeah, we nearly have an answer for this. So the sector is pi r squared theta over 360. And we're subtracting out, twice the area of the sector. Oh, I should actually work that out separately. Minus 1/4 r squared. Also, I hope this person isn't colorblind, because then this color coding is going to waste. Actually, you know, that there's not really a point in factoring out r squared, is there? So that's not very clean, but you know, it's as clean as we're gonna get it, I think. Unless we can make an argument that like theta and r depend on each other, and we can do some cleaning up, but I don't know if there is an argument like that. Am I supposed to get... Oh no, okay, they aren't canceling here. But it feels weird that... Oh no, that makes sense. I was thinking that I was worried about this canceling with that, but that actually makes perfect sense because that's just the area of the triangle. Like we would expect to get just that back out. I need to shift this even more over. Okay, and I think that's our answer for scenario 1. I mean, we can clean it up, though. Why is this negative, by the way? I mean, no, it's not necessarily. No, it's not. Is it? This looks a little bit sus to me because that bit becomes a negative, which I don't like. I'm nervous about this because I think this quantity is bigger than this quantity. And that means it's a negative, which I don't really understand. Okay, maybe that's not as simple as I hoped. Okay, I don't know. I'll think about this some more, but since Thunder's actually here in chat, I kind of want to get to Thunder's question. Because I'm looking at it, I'm not too confident in the answer that I just put now. Okay, figure 1 represents a plan view of a part of a smooth horizontal floor. The asymmetric case reduces to symmetric case easily. Really? Huh. So, oh was saying that you could always make it into a quadrilateral using the circle sector. But the quadrilateral seemed a little bit difficult for me to think about. This we did of what from Paint finally. This is Journal plus. I also have a tablet to write with. Bigger budget, yeah. This free software in the $30 tablet. Huge budget. Okay. Why is AB I shouldn't draw in black on a black image. Why is AB a vertical wall, but it's drawn slanted? Like a top-down view. Oh, okay. That's fair. They do say a plan view. I guess that's what the plan part means. Okay. What did I just do? Oh, I switched to that. The area of the cap is independent of the vertex. The area of the triangle part depends only on the height given the base. Oh! That is a fun observation. So as long as you have enough information to solve the triangle, you're kind of golden. Neat. Okay. Um... Okay, I need to know the formulas involved here, because I definitely don't know those. Part A is okay. Oh! Wait. This is not Euler's number, it's just a constant we have to solve for? Bruh. Frickin' physics. Um... So, okay, you see you have part A figured out, you're saying, bruh. Is that L or I? I assume I. 0.5 kg V minus U. Assume, is V after? Bruh. V is after? Okay. Freaking hell. I plus 6j minus 7i plus 2j. Really? I should be putting hats because I can't bold it. Does a particular value of this mean that it's parallel? And also I'm not putting, I didn't put the units for, who cares about units, man? Units are the worst. Minus 6i hat plus 4j hat. Ugh. The impulse is perpendicular. Oh. And, oh, okay. And so minus 3i plus 2j is clearly perpendicular to 2i plus 3j. Interesting. Okay. Oh, and you can dot them to show that they're perpendicular. Okay, yeah. Um, okay, nice. I guess you find complements orthogonal to walls. So find the value of E. Now, coefficient of restitution, I remember having to Google it to try and help you out with a similar question. I don't remember what it is, though. Like, why can't you compare the magnitudes of the velocity and divide them? That's what I kind of assumed it would be. It's whatever, like, maybe you have to do it with energy or momentum. Maybe just the velocity isn't a good way. Oh, wait. No, that kind of looks like it, right? What are these, what is this I and F thing? Initial and final? Wait, why is it, what the hell? Fenbox saying vector projection. I want a different page. Oh, why do the dot product? Yeah, I mean, you can just do it by looking too, but... Or wait, oh, you mean why dot, or why projection? I still don't get why it's not final magnitude divided by initial magnitude. Do we only need a component of the magnitude that changes? Oh, only the y, or only the component perpendicular gets reduced? Is that it? And the component parallel doesn't get reduced? I guess that would make sense. I don't like it. Okay. I see. So okay, that's why. So component of V MSHAT summer plans? I don't have any right now. Oh hey, there's $10. Component of V along W is V dot W over magnitude of W? Okay, and you're saying that we can use the perpendicular vector, the impulse vector we found here. So we need to find the component perpendicular before and after, and then compare those. I think we're gonna need a negative sign somewhere in here, right? Or let's just see what numbers we get. Yes, okay. So if we take 7i, oh my god, plus 2j. We need to, oh yeah, true. We just care about the magnitudes, don't we? Minus 21 plus 4. Which is minus 17. That doesn't make sense. Oh no, I need to divide by the magnitude of I, right? Um, 9 plus 4 is 13. Terrible number. Minus 17 over root 13. What is that emote? The dancing Pop-Tart? Yeah. Okay, so that's the this is the magnitude of the component perpendicular to the wall. Ooh, a 5 streak, thank you. And so now we need the magnitude, or for the before. Now we need the component perpendicular to the wall after. Only then we'd have a dancing Pop-Tart emote. That's because Cold Gold said so. That's the entire answer. No, so I think it's based off the formula for the dot product. V dot W is magnitude of V, magnitude of W, cosine of the angle between them. And so if you take this formula and divide over the magnitude of W, you get this magnitude of V cosine theta. Yeah, if that's what you know, just use that. I think Cold Gold is giving us like a shortcut here, but it should get you the same result as the vector projection. This kind of cuts straight to the magnitude where if this is V, this is W, theta is the angle between them, then V times cosine theta is basically that length right there on the triangle. So you could think of, in this length along the bottom part of the triangle is the component of V parallel to W. So that's why it works out. We can just do it the vector projection way. It's a little bit longer, but that works too. And if that's what you know, then we can stick with what you know. To be honest, I would have done the vector projection way without cold gold putting that hint in there. So I didn't realize this is even a thing. I think they get the vector projection formula basically by doing that. Let me send it to you. Okay. I think you sent me the answer already. Okay. There is an over root 13 in there. That. Oh, hey, good. Okay, I got the first component right. While you work on sending me that, I'm gonna work on the after component dotted with the impulse. I hat plus 6 j hat dot minus 3 I hat plus 2 j hat over root 13. Does that... Okay, it does match with the other one. And they're not even rationalizing the denominator there, which is kind of based. Actually, this is a lot easier if you don't rationalize. Let's be irrational, because we're about to divide these two numbers. I assume you do final over initial. Yeah, that makes sense, because otherwise it won't be less than 1. Nine over root 13. And I'm just taking the absolute value of these numbers, because we only care about speed. 9 over 17. This feels like an answer that Penn Center would have on one of his tests, because there's 17 in there. Okay, then that does match. Nice. A dot B over magnitude of B squared. Oh, for projection? This is your test? Yeah. This is the same thing? Or, ooh. What do the brackets mean something special? So, okay. I don't think the brackets mean... If you have A dot B over just the magnitude of B, that's the same thing that we got up here. So that's that piece of the formula. But like we said, that's just the magnitude of the vector, and that's okay because that's all we cared about in this problem. But in general, if you want the actual vector, you need to multiply it by the unit vector. That's a scalar multiplication. I don't know if that's a good... I'm gonna do... no, that's not... It's not... Okay, you know what? I'm just gonna... You need to take the magnitude of your desired vector and multiply it by the unit vector that's in your desired direction. And the unit vector parallel to B is the B vector divided by its own magnitude. So then if you scalar multiply these two numbers, you get A dot B, a scalar. On the bottom, we have two scalars. Those all need arrows, by the way. So magnitude B squared. And now as a vector B, I guess that's why the square bracket's there. So the magnitude is squared because one of the magnitudes comes from making a unit vector. The other one comes from the other piece. It comes from getting the magnitude of the parallel component. Put the 19 in parentheses. Oh, like that? Yeah. Can you draw? Yeah, sure, sure, sure. Okay, so I'm gonna make them obviously different lengths. A, B, we don't really need it right now, but theta. Okay, so this piece in green is that length here. For the same exact reason that we said earlier. You can just use trig. This here is a vector of length 1 that is parallel to B. So it's like that vector there. That could be like, you call like B hat. I don't know if that's confusing though, but same direction as B, but it's magnitude 1. So we take the magnitude 1 vector and scale it up by this green length. And that gives us the total vector that is parallel to B there. Okay, awesome. Yeah, it's a little weird process where you're taking the entire B vector and you're always cutting it down to 1 and then you make it bigger again. It's a little bit like backwards, but it's just like, it's a uniform way to always do it. And I'm glad you asked this question because I don't know if I even understood this until you asked me to explain it. So I'm learning here too. Can you understand the problem? Okay, awesome. Just one last bit? Yeah. Can you simplify the A dot B over mod B to A dot hat B? Ooh. Yeah. Um, I think I agree with Finbox there. I think that works. Yeah, I never thought of it that way. But yeah, I think that's just like, yeah, I think it's like generally true. You don't even need like a qualifier. A unit vector I want to project on. So A dot, the unit vector I want to project on, gives me the magnitude. Yes. Yeah, that's what we were saying. Hey, Raven, slay! Now derive the cosine rule. Wait, is the cosine rule like the law of cosines, or is that or is there a cosine rule with vectors? I feel like there's a cosine rule with vectors that I'm just not coming to mind right now. Projection ain't so bad after all. Thanks. No worries, Thunder. I can never remember the formula for vector projection, but I feel like I actually know it a little bit more intuitively now. Well, I mean, I always knew it's like the component thing, but I feel like I have a better feel for it now myself too. Or is this the cosine rule? I don't know. Oh, okay, yeah, it is like the law of cosines. Oh, I guess there is a vector. There's a dot product in there. It isn't there. Damn it, cold cold. Now I'm interested. Um, seeing Dennis Aru? I'm probably pronouncing that wrong. The MIT most variable calc course. I assume you would take C to be that vector or the reverse. And so Aru, okay. Aru is what President Nixon says in Futurama, so that's where my mind went. He was like, Aru! Um Aru makes more sense though. In class 12? Okay. It's is C B minus A? Is that all this? I can never remember how vector addition and subtraction works. Wait, no, okay. For vector addition, you do that. Okay, yeah. I just answered my own question, right? So then if I define C like that, then C is B minus A. Wait, here's A, here's B, here's C. Over here in this situation, A plus B equals C. What am I doing again? I would have C minus A equals B. So here, it's A minus B, I think. Ugh. Okay, there we go. A equals B plus C. Okay, and I have the same thing just with subtraction. And so we want to find the magnitudes of these things. And so are we going to do, I mean, if the vectors are equal, or, if this vector relationship is true, the same should be true of their magnitudes. I would hope. Draw perpendicular to A? Maybe I'm going the wrong direction. Okay. Like that? Triangle inequality? Aw. Okay, fine. I'll get rid of that. From up. Oh. Oh my god. What even is a straight line? That's definitely perpendicular. Don't question it. um. So is this saying this feels like this Pythagorean identities or like can't we Pythagorean theorem says the magnitude of b squared is equal to the projection. I hate this notation. I always forget which vector is which. I think a small b onto big A squared plus, I guess, whatever that length is. Do we can we express that in vectors somehow? There is an orthogonal projection thing, but I assume we don't want that. Maybe we do. I don't know. I want to involve C somehow. Problem I sounded this the other day. Me Machine Rex had posted in Pens Discord. Oh, interesting. Just warning, I might have this B and A switched. So I just don't remember how the notation works, but what do we do with that I don't know what to do with this perpendicular length. The only thing I think to do is like in general set up a Pythagorean theorem with magnitude of B. But like what do we know about this perpendicular? Oh. I mean, is that we could do it? I mean, at the same time, we could also say that we have a right triangle on top too, right? You don't think you need the extra line inside the triangle? Okay. Never mind. Okay. I wanted to throw this away because I'm getting in the weeds. I don't know what you do. There's no way. Like I keep wanting to draw this perpendicular now and just work each right triangle, but I don't think that's what you want to do either. Oh, that's how you make it magnitudes. Or wait. The magnitude of A squared. Okay, wait. I understand. Ugh. I understand that relationship. I don't understand this second equality. How do we make this claim? A equals B plus C. Oh. Oh. I get it. Okay. Oh, that distributes? No, yeah, I guess it. Oh my god. Okay, that's kind of neat. Wow. That's really quick. Wait. Isn't this theta though? If it comes from B, oh no, B dot C. Um, the theta, theta should be this angle, but I'm trying to justify it because like the law of cosine says it. No, 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 no. It's just this angle. Because A is over here. And the law of cosine says it should be this angle here, and that does make sense with doing B dot C to get that angle there. Okay. I feel good with that now. X Ninja. Time I was going to sleep after my lecture ended, nearly 3 a.m. night. Oh wow. Yeah, we were pursuing a little like task here to prove the law of cosines with vectors. You do pi minus that angle. Oh, dang it! I thought that's annoying. Wait, so we're saying, oh, okay, yeah, because it should actually be theta is actually that angle there, and so you do pi minus that. No? Wait, what? No, I'm sorry. I blah. It's getting us that angle. Okay. But the angle we want is the one inside. No? Oh, sorry. I didn't see which one you're saying no to. I hope I have it right now. I feel like I do. Now it's fine? Okay. And then cosine is in, well, I'm just gonna call this an identity. I don't remember how you justify it, but I don't care. you put a negative sign out front, and it's the same thing. There we go. Sorry, this is, wait, no, 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 no. Is that doesn't feel right. This shouldn't be the same theta, right? I define this backwards. Ugh, okay. This is theta. This is pi minus theta. I think this makes more sense of cosine pi minus theta, and then you simplify it. Oops, that's still pi minus theta. And now you bring it to just theta. That makes more sense, I think. Ugh. Um. All right. Good luck with your exam tomorrow, Ninja. I stream also on Twitch. I consider my primary platform. There we go. All right. That's neat. See you, Ninja. Yeah, I stream to YouTube too because there's very little cost in doing so, but the community on Twitch is a lot cooler. There's some cool people on YouTube too, but um, Twitch is a lot more. It just like has much more of a community, I feel like. Okay. We're done with Thunder's problem. We're done with the little Law of Cosines investigation. So, since I don't have a different question queued up, I'm going to return back to this question I started the stream with, which was sent to me. What is the area of this concave triangle? I want to investigate more an idea that Cold Gold said. But before that, to catch everyone up, I was, they asked this very open-ended question, which just kind of piqued my interest. And so I set up a scenario 1 where we make some assumptions about it, where the arc, like that arc, is part of a circle, and that these two side lengths are the same length. So that's why the concave triangle part is in quotes. The person didn't really specify a curve. They kind of said that this geometry problem just kind of came to them. They're a ninth grader. So we don't have a strict definition for that curve. I'm taking it to be a circle, like an arc of a circle. Because I think if you want to do an arbitrary curve, you're getting into calculus. Dart if they're equal? Wait, is dart the name of this object? I think the person would be interested to hear that. Oh. Okay, it's not quite a dart, but it is similar. That's neat. That makes sense it has that name. Now I feel like you have a different calculus problem where you could use a dart, or you could start with a dart, but then continuously break up like BC and CD into like smaller and smaller segments to approximate a curve, but that's probably, let's not go there. Okay, so let me I'm going to delete this page. I'm going to delete that page. I'm going to add a new page. And let's set up scenario 2. I want to make a point here of keeping that arc part the same. No. Well, then what to do? Subtract out the area of the cap. And I feel like that's maybe all that needs to be said on scenario two. Like, yeah, I have a bachelor's in applied math. Hey, sodakai.com. Can you do some basic linear algebra? Uh, if it's basic, yeah. You're trying to learn machine learning? Oh, nice. Um, yeah, feel free to ask a question. If you're interested in linear algebra, you might be particularly interested in Penn Center's stream because he's been doing or he's been helping like facilitate a reading group on linear algebra. Yeah, and there's actually just a stream about it this morning. Um, I can do some basic linear algebra stuff, but I'm not super strong in it. So it depends what the exact what question is. But yeah, I'm happy to give your question a try as well. Have next semester. Ooh, nice. Okay. I'm applying for a graduate degree. Yeah. I'm not currently studying though. You learn neural networks for your master's? Ooh. That's awesome though. I mean, is an ellipse, would that even be nice? An ellipse could be kind of hard. Ellipses are kind of annoying to work with. Planning to study course on algebra as well. You're a data science student. Ooh, nice. Yeah. I'll show the. I got sent. Like, this was basically what I was sent. Paraphrasing, but a very open-ended question. The person just kind of had this thought pop into their head of, what if you have a triangle with one curved side? How would you find its area? And so I was putting on my own kind of conditions on it and kind of like thinking about their question in different scenarios. And so I think the clever way of doing this, well, actually, there's probably multiple clever ways of doing this, but the one that I came up with is that this is almost like the reverse of a circular sector. So you can figure out the area of the circular sector and then just cut out that little end cap part. And integration would definitely work. The person who asked it is in 9th grade though, so I'd rather avoid calculus. I want to avoid trig as well, but I couldn't figure out a way to avoid it. Triangles can be concave, but a concave shape is a shape that has 2 points enclosed within it. Sort of a line segment. Yeah, and so this person, I don't know of a better term to call it than a concave triangle. It's a term that they kind of just made up in their own head, and I don't know what you would call it, but yeah. Everyone seems to know everything here. Yeah, Rex. I usually feel like the least like qualified person, both in my own stream and when I watch other math streams. But that means I have more that I get to learn. Oh, it is kind of like a Star Trek badge. Yeah, you're right. Oh, and you know what, Soda? Since you're a new face, I like to let people know that there's a little community of people who stream math besides me. So Penn Center's on this list too, but if you're interested in math streams in general, or a lot of people can help out with linear algebra besides just Penn Center. So whenever I see people, I just like to let them know that I'm not the only one who does this. Solution vertical length curve is simple. Otherwise, yeah, I completely agree. I was even just trying to think about it if it was a part of an ellipse, and I'm not sure how I would do that, but I assume there is some nice geometric solution for a piece of an ellipse, but there might not even be. But I think it's in a place where I can send this to the person. Well, okay. I mean, I am kind of interested in looking at the other suggestion we had, which is let's draw scaling. If you complete the quadrilateral using if it's still a circle sector, like, can you examine this quadrilateral and find its area? The curve you might not still be able. Well, no, you could always deal with the curve. If you could find the total area of this quadrilateral somehow. Pi AB? No, no. This isn't necessarily a circle length though. Or is that still true? What you put Fembox? Wait, area of an ellipse. Okay, yeah. For a second, I thought you meant that like for whatever reason, like this shape would have an area pi AB. And like, oh, that might be helpful, but no, that of course that wouldn't be a thing. No. You're fine. Um, yeah, I don't know how to deal with this quadrilateral in a way that's substantively different from what we've already done. Hey Mega, it was a question that was sent to me by a ninth grader, just kind of invented it in their own head. And so I'm trying to like it's basically this open-ended question up here. So concave triangle is a term that they made up basically for a triangle with one curved side. And so I came up with a solution to get the area, or we came up with a solution to get the area if this curve is a circle, like an arc of a circle. And we're kind of discussing what happens if it's not necessarily an arc of a circle, but that gets way more complicated. Reaper, how's it going? Free Daisy's been going good. What's not? Yeah, exactly, Rex. For like some polynomial, you'll definitely need calculus, I think. Teratar, no, not necessarily. I'm doing good too. Thanks for asking. I saw Nos for Peralta with some friends last night. And I really liked it. Splines? Oh yeah, for like defining a weird curve PHT, yeah. If you can have random curves, you need to be able to find the area under the curve, yeah. So the only thing I don't like about what I've come up with is that I'm using trig for a piece of this, but I don't really know how to avoid it. Other than that, I think this is pretty... Oh, you know what? I was kind of suspicious of the answer that I got. Cosine and sine law to remove geometric. Ooh, really? Or to remove trigonometric. And yeah, Taylor, for the A and B thing, that was just like considering a completely different case where you look at the quadrilateral that the sector and this concave triangle form. I just kind of drew it poorly where R and B look like they're the same line, but they're not. Yeah, I thought Nosferatu was great. I've seen the 1970s version of that movie that Eggers was inspired by. I like that one, so I kind of want to see the new one. I highly recommend it. Like, it's a really beautifully shot movie. Like you could take a screen capture at almost any point and it will be like a painting. Um, and so does anyone like that too? Oh, nice. So wait, we're okay. Now we're thinking about this isosceles triangle and getting the area of it without trig. And Amit is suggesting cosine law and sine law to remove trig. So the law of cosines would give us this half length is going to be 1/2 r squared minus 2r squared cosine theta. Rooted, right? Ugh. Can't fit that root in. Ah, really? No, bring the line. Thank you. Another 1/2 is too far away. Okay. That's getting a little bit messy, but you're right. And then are you saying we can get rid of the cosine using the law of sines? I don't see that piece. Consider two separate triangles and use Heron's formula of the semiperimeter of a triangle. Oh, I forgot about Heron's. Oh yeah, yeah, I didn't quite mentally do the law of cosines right. There should be. Ugh. There should be a 2 right there. But then we could factor the 2 out and bring it out front. And I apparently just refused to show my work. Really? It's just like, it snaps up there. Ugh, okay, fine. It's gonna live up there. What is Heron's formula again? So I've definitely seen it before, I just always forget. Heron's formula involves triggering the derivation. Oh, funny. Oh, Meggy, you just know that. Okay. We don't know the area though, right? And we're missing a side. I think we need an extra piece of information or something to use Heron's. Unless I'm missing something. And it's on the end of the world if we include trig. The person might know it. It seems like it's just, if we're given an angle, it's hard to avoid trig in some way. The other thing I'm wondering is if I'm giving myself more information than is strictly necessary. Like, if we already know how this triangle up here is formed, couldn't we figure out what this circle must be? That's probably making the problem a little bit too hard, but I'm giving myself r and theta as already defined. I feel like you don't have to do that though. I don't know if I want to go there, but I think this is a, you know, a pretty substantive response for the person who asks the question. There's a formula for the area of a cyclic quadrilateral that specializes to Heron's formula. Then one of the sides has length 0. Oh, that's kind of crazy. What the hell? Have an infinite number of different circles through those 2 points. That's true, I guess. Yeah. Yeah, alright, fair enough, $10. You need 3 points to define a circle. Okay, yeah. I like that point. This had required you to use trig, so in the end... Yeah. Yeah. Okay, can I get just these last 2 pages? Because I... Freaking journal plus plus. No, wait, what did I... Oh, no, I just hit something I didn't mean to. It's okay. Delete that. Let's just do print. Good old print to PDF. When in doubt. Oh, I don't know what page number I want. Do you think I know what page number I want? Journal plus plus? Wait. Really, Pen? This is from Larcy on Discord? I'm gonna copy paste in the exact thing that they... Oh, I guess they asked the same question to us both. So this is exactly what they sent me in the Discord DM. Two linear line and curve joining both of them. Okay, so I don't think they actually mentioned that arc length being the same. So it's basically like an equilateral triangle, but you warp it to curve one of the sides. Oh, okay. So what I said is still true, but I think you don't need... We can be given less information. We don't need to be given R and theta that I kind of gave us. So that might not be in the spirit of what Larcy's asking about then. Hey, Famished. What class do children learn trig in USA? Yeah, it's not actually a required class when I was in high school, at least. I learned trig at like 16 to 17 years old, I think. So I did geometry, algebra 2, trig pre-calc. Yeah, and then I went straight to calc BC. You can do it. Some people do it a year before, at 15 to 16 years old. And even earlier, I think, if you're a STAR student. But some people don't do it at all. Brahmagupta's? Oh yeah, it's the song. Turn it up. Hey, Indian Scouser. Hope all is well. Could you repeat this question again? Yeah, just 1 second. Territar, I miss a thing from lower level trig Sokotoa is taught in 9th or 10th grade. Oh, yeah, you might learn Sokotoa a bit earlier. I don't remember, to be honest. Okay, so Indian Scouts, it's just a problem that I was sent. It's very open question. Like, what is the area of this shape here? A triangle with one side curved. And so I was putting some assumptions on it and solving those problems. So I started with considering equal straight sides and the curved part is part of a circle. The same technique would apply to unequal side lengths. But I'm just learning from Penn Center that their question might have been slightly different. I think I'm still going to just send them this, though, because I think I spent enough time on this question. And I seem to send it to multiple people, so... It's an interesting question to think about, though. Oh, okay. Sokoto comes early in school. Seems like pre-calc level trig isn't as universal. Yeah, I'm trying to remember. It's like Sokotoa. I don't remember when I learned. It might have been in my regular geometry class when I was like 14 to 15 years old. I honestly don't remember. Which math? I mean, that's funny, but then like all of us are solving the exact same like problem without knowing it. I don't know. All right, so pages 17 to 18. I'm gonna print these out and send them. And by print, I mean print to PDF. You never solved anything? Okay. Okay, that's good. It's like I feel a little bit bad if we all are doing the same type of work, it feels like just an inefficient use of time, I guess. But I don't know. Larcy concave triangle. Like it's a waste because it's what's fun to think about for my own sake, but I don't know. Okay, make sure this PDF is what I wanted. It sure isn't. I got the page numbers wrong. Ugh. What am I? Oh, did I just not remember what? Ugh. Okay. 17 to 18. I think I put 16 to 17. Bitch tit, thank you for the follow. Welcome in. Ugh. It's a good name. Hello to you. Okay, now I got the PDF right. Let me just send it off to this person. Hey, Lucas. Okay. Okay, what's being put in chat? We can't impress her with our intelligence, we'll confuse her with our BS. True. I'm terrible at math, but definitely interested. Oh, hey. Well, welcome in. Oh shit, I'm missing some YouTube chats too. But basically, the theme of the stream is I take math questions from chat, and then if there aren't questions in Q, I kind of choose my own thing to study. So we're just looking at finding the area of like, what if you had a triangle with one side curved? And so we just spend a good while thinking about that. But yeah, I also do some game streams sometimes. And since you're new here, I do like to let people know that I'm not the only one who does math streams. There's a whole bunch of people who stream math besides me. So I just like to let people know that even if I'm not around, you can still get your questions answered from someone, or just see how other people like to do math too. Okay, let me check in with the YouTube chat and then I'll catch back up with the Twitch chat. Just integrate area of triangle. Yeah, I mean, I want to avoid calculus because the person I said is in 9th grade, but you could definitely do this with calculus. Yeah. Algebra 1, Geometry, Algebra 2, pre-calculus usual order. Yeah, that's order that I did it too, Territar. The thing is, right as I graduated high school, California is switching to Common Core, so it's all messed up now. I don't know what it's like in my state now, but any questions on electric circuits in the pipeline? I could potentially get one in because I've been reading about electric circuits, but we have a question from Lucas to get to, and then from Shanktrix, it looks like. So not anytime soon, potentially. Oh, really, Territar? Okay. I have been reading from this book, and I've just been working on AC circuits, actually, which do some really cool stuff with complex variables. It's in the math chat and the server. Which server? Sorry, Shanktrix. In like the elements? And then Lucas, what's your question? The elements? Okay. I have not read the art and craft and problem solving. Femlox has, though. Okay. Thank you, Lucas. In the elements? Okay. Books are fun. Hey, Draft Fusion, yeah. Okay, let me look in the elements for Shanktrix in math chat. Are you Abhay? Do you have this weird circle triangle thing? Okay. Okay. Do the physics book like that they provide a way to check what you learned so far? Oh, nice. Had to recreate it from a puzzle my math teacher gave me. 10 is the radius, 15 is the outside length. Oh, okay, so I get it. 10 is the 1 bar. And 15 is a 2 bar. And what's the question? Total shaded area. Area of the individual colored shaded areas in the orange angles. Oh, geez. Okay, so I'd see how to get yellow and green. I think we can safely say yellow and green should be the same value. And it'll be part of blue. Okay. The circle is kind of funny here. I don't think we're going to need the circle that much, though. Okay, so if we have... Let me make a simpler version of this picture. If we have a circle of radius 10, And then we draw an equilateral triangle. With each of the sides 15. Yes, it sounds good to me. To be honest, I'm kind of like booked up already with like the things that I'm reading, but that's what I'll keep in mind. You post it, you send it to the Discord. Okay, let me take a quick look at it. If it's something really quick, I'll switch gears and do that. If not, I think you'll be second in queue, or I think you'll be like next after this one. Yeah, the equilateral triangle does seem a little too good to be true. Oh, okay. It looks like that one might take some time. So yeah, Lucas, I'll work on yours after. And your puzzle. Oh, that's not twos, or that's not like a two bar. Oh, that makes this a harder problem. Okay. um. Okay, but yeah, it is geometrically possible then, on the bright side. 9 odd, I see your question. I have this problem, another question, and then I can look at your question. If you aren't able to stick around until then, I put timestamps on my YouTube recording, so you can come back to it and look at it if you aren't able to hang around until then. After I do Shanktrix's question, we have a question from Lucas in Discord, and then looks like a pretty common like Calc 1 question from 9 odd. But yeah, if you're able to stick around until I can get to your question, just feel free to check through the YouTube like VOD or like the recording. Radius is 10, yeah. Wait, this has to be equilateral. I don't think this is possible. Because if all of these are also length 10, like, the triangle just has to be equilateral, I think. It does look like a logo, Suna, yeah. I'm not sure this question is possible. Because if these are all radii, send a better picture, okay. Okay, now we might be talking. Let's get rid of this one. Well, yeah, but the problem was that the radii were still there. It kind of breaks the whole not equilateral thing, I think. No, they're not areas, Cytos. Yeah, it's not like 15 is like the 2-bar length, and 10 is the radius, the 1 bar. Okay, well, wait, we have another issue though. This orange, is it possible for this orange angle to be the same as this orange angle? Oh no, maybe it is. I see they're both orange though. It does look wider. I'm trying to think about it. Not visually, though. Ninod, I already copied your question down. You don't need to keep putting it there. The bottom angle be 2 times wider? I don't know. There's a theorem for that. Oh, maybe. Made it orange tried it. Okay. So let's say top one is single orange, bottom one is double orange. Insidos may have like pointed out the key for those two anyway. Oh, I've seen this before and I meant to save it. Oh, nice. It's that upper right one. So yeah, the bottom one is double. And actually, hey, that means I labeled it appropriately, you know, double orange. We're doing inscribed angle theorem unit right now. Hey, Silverbird. Yeah, I mean, with this type of geometry, I don't know all the theorems involved, but I don't know. It's like 120 in the blue one. I mean, it looks like that, Suna, yeah, but I definitely wouldn't want to measure this like visually. That's usually like cheating. Oh wait, I didn't even notice. We have to do these orange angles here too. I guess triple orange. I assume those are the same by symmetry. Yeah, radius 10, the double bar length is 15. Thank you, Terratar, for putting that like start there. Are you just calling the answer, Draft Fusion? I haven't even gotten that far yet. Hey, our dose of internet. 7.5 definitely seems possible. So okay, actually, oh, you know, this isn't too bad, I don't think. Let's take like one of the, like, this is an isosceles triangle here, right? So let's just like put it like this. 15, 10, 10, right? Oh, 7.5, I see, yeah. So here's where the 7.5 comes up. What subject do you choose in grade 11? That's a tough question. What did I do in grade 11? Trig / pre-calc, I remember that. I don't remember anything else besides, like, I definitely did an English class and a Spanish class. Yeah, I'm sorry, I don't remember what I did. Why can't trig not be used here? I probably could. We're gonna need trig at some point. Oh, what science? I don't remember. I mean, I definitely did physics. I don't remember if that was senior year or junior year, though. Or like grade 11 or 12. Yeah, you can definitely cut the left, or cut the triangle in half. Oh, and Puike, I didn't say hi to you. Almost no professional mathematician uses school geometry after graduating school. I think that's a bold statement. I think engineers would all the time. I mean, I guess you wouldn't consider them mathematicians, but like it gets used a lot, I think. I think you would also do a lot of more numerical approximations and not painstakingly doing proofs. Are you a full-time streamer? I pretend to be one, Silverbird. I don't make enough money to make a living off this, but I'm also not employed right now, so this is what I'm doing to fill in the time. Okay, so I like the idea of just considering this right triangle here. And the Pythagorean theorem tells us something about that height there. I'm going to let a calculator do that work for me. Square root 100 minus 7.5 squared is definitely a number. Give me the exact result, Wolfram. You're not going to give me the exact result because you're a jerk. I guess there's a decimal in there. Okay, 6.61 it is. In 12th, I did a fun half semester of astronomy. Oh, that sounds awesome, Peach. I would have loved to have that. As a kid, I never liked to do math with playing cards, as we do multiplication with those cards. Oh, that's weird. Does it mean I can't get a job with my statistics degree when I graduate? Oh, my life. I knew I should have done CS. Don't worry, a college degree in general doesn't... It apparently doesn't help you as much as people say. Doesn't matter what you choose. Oh, it's 5 root 7 over 2? All right, thank you, Cytos. Absolutely, to do the exact result. Hey, syntax error. Actual mathematicians. I mean, I'd be curious to... I feel like I always hear about people talking about algebraic geometry. I wonder how much that regular geometry that includes, but I don't know for myself. No, actual mathematicians do like non-Euclidean geometry and stuff too. Like it's pretty fundamental, I think. Yeah, so the area of this triangle over here is 1/2 times 15 times 5 root 7 over 2. And that's a number. 15 times 5 is 75. Root 7 over 4. Okay. I think we're nearly done with the problem, to be honest. Can you please explain the difference between geometrical and binomial distribution of statistics? I think the quick answer is that is the geometric the what, like the first? Like, okay, here, I'm sorry, Arlidas, I'm gonna have to put you in the queue though, because I'm gonna have to Google it. And this is what the queue is looking like right now. I don't remember offhand. Sorry about that. But if you're able to stick around until then, I do like put timestamps in the YouTube recording so you could come back and look at it. I'm sorry about that. We got the same area of Femvox? Okay, nice. Yeah, syntax error, like, it's a number, you know? It involves geometry, though, Puika. I don't know. Is 7.5 radius of half circle for orange? I don't know what that part means. Some fractional calculus? I've heard of fractional calculus. I haven't really done it, though. Okay, so we can get the area of the shaded regions right now. So the area of shaded regions. Oh, do we have to find them individually? Ah, we do have to find the individual areas. Ugh. Oh, that's so hard if it's not equilateral. How do you do that? Oh, okay, we need to solve for the bottom triangle. Okay. Bruh. Okay, we're not almost done. I was being optimistic. We can get all the angles, though. Let's think about the angles first before the area, I think. And thanks for talking about that, Territar. Okay, I think if we want to find, oh no, I'm saying we're doing the angles first, right? So let's start with the triple orange because we have that directly in that triangle there. And actually it's easier to work with that angle and that triangle there. So, that's triple orange, that's triple orange. So the triple orange angle, which is like cell phone reception bars, is equal to, we need trig for this. We can take any trig function. Let's do arc cosine. I think Sutsun was saying arc cosine before. 7.5 over 10. And what does that come out to be? We're going to keep it as arc cosine, but just to cosine law for angles? I think this is a little more direct, isn't it? 41.41. It's kind of a neat number. Well, I said about, so I'll just say I won't make it repeating. And so that means that single orange is double that, right? Because it's made of two triple oranges. So single orange is 2 arc cosine 7.5 over 10. It wouldn't be repeating. You're right, Cytos. I just wanted it to be repeating because it is 41.41. Oh wait, it's exact. I did, bro. That's exact. I know I'm saying bro a lot today. Bro is the word of the day. Okay. I just kind of assumed that it would be an estimate. Degrees. Series expansion for integral square root ln x. Some nice fractional calculus tricks to get it, but it's not working. Oh god. I've done like one problem with fractional calculus ever. What if you figure out the angle between two single lines? The law of cosines for that angle is also perfectly fine. This just feels a little bit quicker to me, at least. Figure out the angle between the two single lines into the area of the total blue circle. Ooh. Yeah, Lucas, that's not a bad idea. I was gonna do it a different way, but that might be quicker. Okay, so we can work out what double orange is. That's correct. You're on 41.5. Okay, fair enough. If I'm thinking about triple orange next, or, I'm sorry, double orange. Oh wait, no. Cytos already answered that. We could figure it out a different way too. So actually, Shanktrix, I don't know what works best for you. Like, if I just could we just invoke this random ass theorem here that like 2 people in the world know about? Or do you want to solve it a different way? Because I can see a different way to solve it too, but I don't know what's better for your thing. There's a neat proof for that. Oh, nice. Do the angle theorem if you want? Okay, then let's just use that theorem because it's a lot easier. Okay, we're already on orange. So then double orange is twice of single orange. That's a kind of a nice progression where you just keep multiplying by 2. Didn't know I was top 2 in the world? Yeah, Fenbox. Someone who plays with yo-yos would make it a math problem. Yeah. Math problem should be solved in whatever way you want to. If you're a tutor, I hard disagree with that. In general, sure. But I think of this as like a tutoring like stream, and in that context, I really disagree. If you didn't know these, you don't know geometry? Oh, I sure still don't know them. I also don't know geometry though, so there's the there's the answer. You didn't know to memorize fully stopped. Oh, I'm sorry, hourly doesn't matter. I saw that and then I got distracted. Not really any, just using it a lot, unfortunately. Like, and the more you use it, the more it sinks in for me. But what Teratara is saying, but like pretty much. Okay, so all the orange angles are solved for. And so now we can do Lucas's idea where this is the sector of a circle. And so we can get that area without much difficulty. Yeah, I like that. So that's the sector of a circle. So it's going to be pi times radius squared, which is 10, times double orange angle divided by 360 degrees. Assuming that we take the answer in degrees rather than radians, but either is fine. You don't want to know how my ego is right now, bro? Congrats. Yeah, we might just take it in radians. It's not too important. So it's gonna be pi times arc cosine 7. Oh wait, 4 arc cosine, right? Over 10 divided by 2. The little model is gonna use it in radians. 4.54. Does that make sense? I think it does. No, that doesn't make sense. Yes, I think it does, yeah. 4.54. Does it, though? The entire area of the circle is like 300. What did I do wrong? I forgot the 10 squared. Bruh. I said bruh again. I forgot to multiply by r squared. I forgot that this is 100. What? Okay, that's too high though, isn't it? Yeah, me. That's the real chat answer. Just know how to derive everything. I always for me though, it wasn't always easily possible as a student. Remove. Oh yeah, it cancels. Thank you. Doing it all wrong. Okay, 144. That's a reasonable answer. 144.55, we'll call it. And since I made that in radians, we'll too high. Shane, thank you so much for the raid. How's your stream? What were you doing? I really appreciate that. Adventure. Welcome in, Matt. For anyone who's new around here, I'm Don. I do actually like math help streams like this, and we're just looking at this problem here. Big Tuna, welcome in. I also do some video game streams and stuff like that. Grethard, welcome in. For anyone who's here at my end, please check out Shane. He does some awesome like history streams, I've seen him doing like model painting and stuff like that. So awesome, like educational streamer, cool dude. Matt, thank you for the follow. Pretty chill, doing what I call office hours. I just sit around and take questions. I was building model in the background. Nice. Sounds like a good time. So we're on this geometry problem from Shanktrix in chat. That made me think of 3-phase electrical calculations. I haven't heard of those. And it like some of those things that looks like a logo. It definitely feels like one also. And this problem, we figured out what all our angles are here, and we're working out. I think we just got the area of this blue region here, and then we just have to figure out the yellow and green. What was I writing? I was writing a number here. That comes out to 144.55. About. So yeah, Shanktrix may have a little difference in our numbers because I think you're rounding a little bit earlier than I am, but as long as you're about the same. Mercedes, that's it. Using internal triangle measures to measure the arc of the circle. Basically, yeah. Like, it's kind of weird. Like, yeah, we worked from the inside of these triangles here to figure out this, like, you know, I'm calling it triple orange because I'm drawing the 3 bars. And then that let us figure out the single orange, which let us figure out the double orange. And then Lucas in chat noticed that this blue region is just the sector of a circle, and that has a nice formula for it based off this angle here, the double orange. Yeah, and Lucas has a very big ego now for having figured that out. So we should all bow down. And so now we can figure out the... I think it's safe to say we can just claim that yellow and green are the same area. And we know the area of these 2 white triangles, and we now know the area of the blue region. So let's take the area of the circle and subtract out the stuff in the middle. Area of yellow or green. Let's put it 1/2 because we'd have, like, if we take the entire circle and subtract out stuff in the middle, we still have to cut it in half to get just the yellow or just the green. Sometimes come up with the method of solving something, I can really do the calculations accurately. That's a pretty common problem. Yeah. I make just like arithmetic mistakes all the time. So the area of the circle is pi times radius squared, radius 10. Lucas gets a cookie, exactly. Minus the area of the triangle, we have 2 of them, and that's the area of just one. 2 times 75 root 7 over 4. And we're also subtracting out the sector we just got. 144.55. And that's a number we can get at. Come back to me, pen. K shit G? I don't know if I'm pronouncing... Oh, wait, no, K... I'm sorry, I'm probably pronouncing that wrong, but... Over in the YouTube chat, 1 approximates sin x over x integral. I got a couple of questions in queue right now, unfortunately. So many interesting names. Yeah, we had bitch tits earlier. I'm sorry. I hope the cursing is okay with people who are just joining us. But yeah, we have had some good names in chat. Overcomplicating this. Well, Cytus, you still have to, like, I don't think it's that simple. You still have to worry about the area of the blue sector. It's not, like, I think because it's not an equilateral triangle inside, like, this cap here is not the same as the yellow and green. I think that's what makes it a little bit harder. Read it with the case silent. Okay, so you still have shit in your name? I don't care. I just think it's funny, and I will feel bad if that's not how it's supposed to be pronounced. Okay, I need to... I'm going to mess up the entry here. Let me take a screenshot of what I wrote. We want the area of each of the individual regions. Okay, you just have... Okay. Oh, I do see it's... Shit IJ. Shitage? I'm probably... Okay, you know what? I feel bad just calling you shit, but I don't know what else to call you. Square root. Either way, welcome in. Average YouTube chatter experience. Okay, that's 35 point... We'll call it 2. 35.2. Okay. And then the only other thing the question is asking for is the total shaded areas, right? Yeah, and so that's now simple. Total shaded is a blue plus a yellow. Oops, that's not a 3 at all. That's not a 5. Okay, plus a green, which are the same thing. Like Bart calling Mo to make him say things. I'm looking for Amanda Hug and Kiss. Has anyone seen Amanda Hug and Kiss? It's one that I remember. 144.55, 45.2 times 2. 214.95. I already forgot what number I just said. 214.95. Okay, I think that's the answer to your question there, Shanktrix. It's just a shit name, get it? That's exactly it, Amit. Shitij. So I'm sure it means something else. I just see a curse word and giggle at it. 9 out of 10 marks, did not write units squared. Ah, okay. Well, it's a good thing I'm not being graded. Except by you. Okay. Thank you for the question, Shanktrix. This is the queue as it stands now. So Lucas asked a question in the Discord. Let me go and grab that. Let me put a check mark on a base or Shanktrix's question. Okay. And Lucas, I need to translate your question, which is okay. Let me do that. Lucas, question 2025-01-4. Translate.google.com. Images. And by the way, if you didn't know that Google Translate works on images, then now you know. It's kind of sick. There we go. Why can't I find Amanda Hug and Kiss? Maybe your standards are too high. Oh, yeah, I think you did say that. These are units and there are units, and the problem is so corny. Yeah, it is, Cytos. Sorry that I speak Dutch. You don't have to apologize for that. I'm sorry for where I was born. My bad. Be born in America next time, Lucas. Like, the actual nerve. I can't believe people these days. I also laugh at some names or words in other languages that mean something funny. Okay, good. I mean, yeah, it is an English stream, but it's fine. It's not always easy to translate math. The prescription of the rational function f depends on two real parameters, a and b. We'll have to go back to the original for that piece. How many possibilities are there for the parameters a and b? So let's go back. See axis. Ooh. Interesting. Copy image. Can I get this directly into journal? I can. We have the technology. Where's my select? Okay, there it is. It's because of Google Translate, Fembox. And then I'm gonna go back to the original for the math parts. Okay, so a minus 3x, x plus b. And that part is just y equals x. Okay. Linear transformation. I can make a better photo of his bad. I think it's good enough. I think I understand what the question is. So we have an irrational function of some kind. I think we need long division here. That'll probably make it easier. But like, it's gonna look something vaguely like that, I think, with a vertical and a horizontal asymptote. Oh no. Yeah, we do need long division. It would look like this, but I think the we're asking about is something that looks more how do these look? It's like a horizontal and then an oblique asymptote or slant asymptote, like that. And they're asking, when is this slant asymptote y equals x? For what values of a and b do we get that? And so to get an asymptote like that, you do long division, right? This isn't really a question? Oh no. It did not translate that well. Maybe I'll plug in this thing to Desmos and just see how it looks. A minus 3x over x plus b. And so what do a and b control here? Ooh, that's kind of a funny. Ooh, 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 ooh. Okay, anyway. Oh. Okay, no. I don't remember how rational functions work. It was my initial instinct. The question is really, the function does look something like how I originally drew it. What they're really asking is, when does the line y equals x, that's not y equals x, but we can call it y equals x. No, let's draw it slightly better. When does this like symmetrically cut the function in half, basically? Yeah, okay. I think we're on the same page now, Lucas. You think b has to be 3, so you're gonna guess d. Okay. There's only last note is that y equals minus 3. Yeah, well, what does it mean to be symmetric about y equals x? Like, I'm thinking of like an inverse function. Like, when does the inverse exist? That's not necessarily it, though. Or you're saying, yeah? If the function is its own inverse, right, that's it. And so, actually, I mean, we may as well just keep that there. How would we want to, like, do we want to, figure out when f of f inverse of x? No. I was about to say this, but that's always true if the inverse exists. Okay, no, I think we just need to find the inverse, right? Because we want to know when f of x is equal to f inverse. And we need to find f inverse for starters, I guess. Find g of x and compare the two. If g of x is the inverse, then I think so, yeah. But I assume we're going to like compose them in some way. Or no, we can maybe just compare them, not necessarily compose. Function is zone inverse must have, okay, yeah, Teratar. Multiply each side by y plus b to get xy. Okay, actually no, I shouldn't move too fast here, Lucas. So I'm going to multiply each side by y plus b here. So we'll get x times y plus b is equal to a minus 3y. Now let's distribute the x out. xy plus xb is equal to a minus 3y. And now I want to solve this for y, so let's get all the y's on the left side. I'll add 3y to the left and subtract the xb to the right. So we get xy plus 3y equals a minus xb. Yeah, for an arbitrary line Teratar, it'd probably be a lot harder. Now let's factor the y out from the left. So we get y times x plus 3 equals a minus xb. Now divide out the x plus 3. A minus xb over x plus 3. Okay. And so we want to know when is f of x, the original function, yeah, I think Rex is on the right track here. A minus 3x over b plus x equal a minus 3x over x. Okay, x plus b. It doesn't matter, but when is our original f of x function equal to the inverse that we found? a minus xb over x plus 3. So yeah, I agree with what Rex and Cytos are saying, and I think someone else said it earlier, that there's a 3 here, and a b here, and a b here, and a 3 here. B just has to be 3. If, say, this was a 2, for instance, like, we would get b equals 2 from that first piece, but then also b has to be 3 from the second piece, in which case there would be no solution, I think. But because they both agree to be 3, then we do have a like, the b works out. There's no contradiction. That's like the evaluation they want you to do here, Lucas. Looking at A, we just have an A, and we just have an A. Like, the only condition we get is that A equals A, and that's kind of like duh. And so yeah, I think that's the answer that Fembox called. So we can plug in anything we want for A. For B, we can only plug in 3. B's in top and bottom of f of x and g of x. That's why B has to be a single value. Otherwise, asymptote's in a different spot in g of x. It means B being in the top and bottom, like, it means we get 2 conditions here. What you said, the second part of what you said is exactly right, that the x plus b matches with the x plus 3. It means b has to be 3 to make the vertical asymptotes match. So from that, we get a condition that b must equal 3. From the top, it's hard to see what exactly it controls, but we can see this 3 does match up with this b in the exact same way. So we get a second condition that b still has to equal 3. And because those 2 conditions agree, then we can say that a solution does exist, and it's only when b equals 3. Oh. Why do we equal f of x to g of x? Oh yeah, sorry, so maybe I should have called this g of x to match your notation, but g and f inverse are the same thing in our problems. It's what Cytos said. If the function is, in order for this to be true with the line y equals x, the function has to be the same as its own inverse. Right. So what Cytos is saying there is, if you take the inverse of a function, like, let's just take a parabola for example. If you take the inverse of that, it's like reflecting it across y equals x. And so if you take the inverse of a parabola, you get like a sideways parabola like that. I'm thinking about what you just put there in chat, Lucas, but let me keep on with this thread, and then it might answer your question too. So in general, that's what taking the inverse of a function does. It reflects it across y equals x. But they're asking us, when is the function symmetric about y equals x, as in it's the same? We want a function that looks the same after we reflect it across this line. And that means the original function has to match its inverse. That's the idea that they're trying to say. And so that's why we want to, that's why we're doing this f of x equals g of x kind of comparison. And so I hope that makes sense. And so I think that means the answer is that A can be anything it wants and B can only be one thing. And the closest answer we have to that is answer D. Does that make sense? I think I screwed up my own thing, but not really. I mean, I didn't even realize that we would do that f equals f inverse thing until chat said it. So thank you, chat. Shekar, can you help me to learn function? What about functions, Shekar? And so yeah, the thing you were saying with x to the n, where x being even or not odd, or even or uneven, I think it's a different thing. Yeah, if you want, I could explain that, but that's an entirely separate thing from inverses, I think. I don't think the degree of a polynomial has anything to do with whether an inverse exists that I can think of. Well, I think normally the inverse doesn't exist for a lot of polynomials beyond a certain degree. Shekar, I have a Discord where you can like post a screenshot if that's easier, but either the YouTube chat or in Discord. Yeah. And so I think for a more complicated polynomial, an inverse may or may not exist. I can't quite work that out. If you had something like probably you can probably always find an inverse, but you could have some crazier polynomial that's like that, or you probably could get part of an inverse, but it's going to be really weird. If it's a parabola, that's something that's simple enough that I think you can. And like you said, you gave like the simple example for x squared. Hey, Augustine, thank you so much for the kind words. I hope you enjoy your meal. Second, third, and fourth degree polynomials are all formulas. You can find an exact inverse for all of them. Oh, nice. And DCI Banks, thank you for the follow. Oh yeah, horizontal line test. Yeah. Yeah, that's the perfect thing. Like you can find the inverse always for a piece of the function. Like, you know, you could say this piece right here passes the horizontal line test. Let's find that inverse. But once function, yeah, the horizontal line test is the good thing to like go by there. Okay. So if that's good for your question, I should keep moving through the queue here. Yeah, exactly. It's like, it's the same thing as the vertical line test. Um, okay, so SB, I assume that's you, Shekhar. Okay, so let me... There's a queue of people here. No worries, Lucas. Thank you for the question. Are 9 odd or hourly dose of internet still here? If I don't hear from them soon, I will do Shekhar's question first because they're here. It is you? Okay. You don't need calculus? Oh, you're right. It's going to be a square. Yeah, it's kind of weird. Usually they have one of the sides cut off or more expensive or something. I didn't read it entirely. Okay, I'm not hearing from 9 out or hourly dose yet. So we're going to do Shekhar's question first because they're here right now, and then I'll get to 9 out and hourly dose when I have time. And if you don't mind, just keep the Discord clean. I'm going to make a different thread for you in the Discord. Because you posted in someone else's thread that's already existing. At SB. So I'm going to transfer your thing to here, and then I'm going to delete the your thing you originally posted. Just to keep things, like, sectioned off. Okay. Let me copy that onto the thing. No worries, because I know it's really weird to get used to this. Oh, okay, yeah, we can do this. Okay, so... here we're given values for f of x up here and g of x down here. And we kind of use this as like basically the same thing as we would use a table to look up values. So before we even look at the actual problems, like for example, this point right here, the x value is 2, so f of 2 is equal to the y value of 3. That's how we would read this. Now looking at an actual problem, we want to find f of g of 3 for the first one. And so that looks weird, but we can deal with that. Just deal with one problem at a time. So in f of g of 3, oops, do the inside first. Worry about just what g of 3 is at first. So let's go to the graph for g, and we want g of 3, so we start at 3 down here, go up to the function, and oh look, we're now at 4. So g of 3 is equal to 4. And oh look, well, we know what g of 3 is, so let's come down here and plug in that value. So now we have f of 4. And now let's do the same exact thing, but for f. So we start at 4, go up to the function, and oh look, now we have 1. So f of 4 is 1. So the answer to the first question there, I'd say it's just 1. So that's the second question you see in my tutoring center most semesters. Yeah, it's a good question to like know how to do. No worries. Do you feel like you can do the rest of these now? It's all the same like process here, just going back and forth, but between the different graphs. Yes. Okay. Awesome. Let me know if you run into any issues. Okay. Awesome. Thank you for the question. I need to mark a different question as complete also. Okay. One day this will be automated, but for now, I am the bot. So I did in fourth or fifth grade. I'm probably around there too. I don't remember exactly when I would have done it. Hey, Speedkeeper Saffron. I'm doing good. How about you? Okay, so for 9 odds question, let me type that in chat too. At 9 odd. It's good to hear, Speedkeeper. Just in case I go back through and scan through the recording later, I'll type that in chat to help them out. So I'm going to solve this using calculus, but as Saido's pointed out, you actually don't need calculus for this. If you don't have any other constraints, the maximum area is always from the regular polygon. So in this case, it's just a square. So you would take a square with 10 and 10. No, wait. Sorry. 25 and 25. Because the perimeter is 100, right? Oh, I don't remember what I was doing in 4th grade. Really? Only fractions in 4th? Maybe. I don't remember. I don't know how the early stuff works. Oh, thank you for the sub, Augustin. Welcome in. So let's do the calculus way also though, because I assume that's what they want to see, and we should get an answer that matches. So if we're doing it the non-calculus way, let's assume it's some non-standard shape, or not it's not a square at least. Let's assume a rectangle because we're mostly a rectangular area, and let's make one length. Well, let's do length by width. Width, length. Sorry, algebra until 7th grade. Oh, really? My memory of that is so fuzzy. I couldn't even tell you for me. So we know the area of a rectangle is length times width. That's just something that we're going to want to optimize this. Or sorry, the goal is to optimize area. We know that area is length times width. But the issue is, like, if we want to optimize it, we need to take the derivative of it. And taking the derivative of something with 2 variables, we just don't really want to do it. In a later calculus class, you'll learn you can, but for now, we only want 1 variable. Saffron, no, for a rectangle, it's just length times width. It's not 2 times that. So we can actually, we want to get rid of one of these variables. And we can do that with the other piece of information we know. Oh, sorry. Maybe you're talking about perimeter, Saffron, in which case you are right. So we have 100 meters of fencing. Oh my god, that's a terrible box, but let's use that piece of information here. The perimeter is twice the length plus twice the width. And we know it's also equal to 100, because we have 100 meters of fence. Oh, interesting, Cytos. We can use this relationship here, isolate L or W, and plug it in up here, and then we're in business. Just for fun, let's isolate L. Who cares? It doesn't matter which one we choose. Subtract the 2W over, and now divide by 2. 50 minus W. Now we know L is equal to 50 minus W. Plug that in up here for A. So I'll come over here. A is equal to LW, which is equal to 50 minus W times W. Great. Now we want to optimize A, and when you hear optimize, you should think about taking the derivative. So I'm going to say, okay, it'll be slightly to take the derivative if we multiply out the W first. Okay, so let's do that. 50W minus W squared. Now let's take the derivative. A prime is equal to 50 minus 2W, and because we're optimizing it, we're going to set equal to 0. Subtract over 50. Divide each side by -2, you get 25. Nice. So that means the width, this dimension here is 25 meters, if you want to be fancy. The length, we know length is equal to 50 minus width, so let's do that. 50 minus 25, so 25. So look at that, 25 by 25 square, just like we said initially. So yeah, those are the dimensions that we want. 25 and 25. The area of the rectangle is 25 minus x, 25 plus x. Maxi, yeah, that's more or less what Sidus pointed out. You don't actually need calculus for this problem. This type of question is normally asked in a calculus context, though, so I did the calculus approach. But yeah, you definitely don't need calculus to solve a problem like this. And so yeah, 9 odd for if you're watching in the future. The reason when you would need calculus is if they said, oh, but there's a river on one side where you don't need to build a fence. Then you have a calculus problem on your hands. But if you don't have any like constraints like that, then you're fine. Hey, Matthew. Okay, so that's 9 odds problem. The last one in Q is our dose of the internet earlier asked about the difference between geometrical and binomial distributions and stats. And that I'd like half know it offhand, but I need to like Google it, so that's why I put that in Q. Geometrical and binomial. Like if I remember right, geometric is like what's the probability of your first success happening on X trial? Yeah. Ooh, that's a cool thought, Amit. If you argue that to minimize error, you look for a shape that will be the most stable shape in nature if it exists. You don't want to use calculus. A shape that minimizes energy. That's kind of a neat like mindset. Yes, Sidus, I think that's a good summary. Okay, so let's like type this out. Our dose of internet I don't think is here anymore, but I let them know they can check out the recording after. So let's type this out. A binomial distribution answers the question of what is the probability of getting n successes. Wait. It's X successes and N trials, right? What's the convention? I think it's that. In other words, the number of trials is fixed Okay, let me... There's a better way of phrasing that. Let me talk about geometric distribution, though. Answers the question of... So geometric is very similar, but slightly different. What is the probability of the first success happening after n trials, right? And I think that's the fundamental difference between the two. No, the Bernoulli is like the more general one. The geometric distribution is like more of a special case. Okay, yeah, thank you, Cytos. Let me include that too. Yeah, there's a weird lack of stats questions that come through not only my stream, but I feel like every math stream that I watch. And I feel like stats is like, normally students need a lot of help with stats. And I can't really figure out why we don't get that many questions. But my stats is definitely like, it's gone pretty rusty. What is the probability of rolling 2 6s from 5 dice rolls? Yeah. In your example for geometric, I like those examples. Thank you, Cytos. Yeah, like when I was a tutor in a center at Fenbox, it was kind of the same. Stats and then calculus was next, I think. So I feel like, I wonder if we're like collectively doing something wrong that's like repelling stats students or something. So yeah, so I think this is hopefully good enough for awareness of the internet's purposes. Binomial distribution is a special case of binomial distribution where a single trial is conducted. Oh, sorry. Yeah. I've been saying Bernoulli, but yeah, binomial is probably the more proper term. Math questions, not stats. Apparently, Maxi. Yeah. Is this part of the standard high school curriculum? To be fair, I don't think it is. I think I only had to go up to Algebra 2, and you could do stats after that. If you want to get a degree, though, I remember always being... You have to take calculus if it's a hard science, and you have to take stats if it's a soft science or almost anything else. And so a lot of students have stumbling blocks on those two things for math. But for high school, I don't think so. I took stats, but I'm also a nerd. I don't think most students do. But yeah, I guess you would say both binomial distributions and geometric distributions rely on Bernoulli trials. But binomial and Bernoulli both start with B, so, you know, let's get them mixed up. Human brain is bad at making sense of data. You can easily lie to them by skewing data. Use channels even on graph axis to show big bars. Yeah. I mean, yeah. If you want to be really sneaky, you get like a logarithmic scale on there. Okay, I think we've gone through the queue of questions though. Oh, truncating the y-axis. That's evil. Okay, I think we can get rid of this page too now. Also this page. Also this page. Let's do some cleanup on this thing. Maybe we'll do a physics question or two and then wrap things up. I am still kind of struggling with losing my voice, so I don't want to do as long of a stream as I otherwise would. Where did I leave off on the physics? It's been a minute. What's this? Manipulating p-values? Oh, I bet that happens. 50-50 split, guys. Oh, that's really funny. And the joke here is that they have truncated the y-axis here, so it's actually 95% all the way down to 0, but they cut off between 0 and 90. So it looks like they're even. I did 17, and that one seems like it was a doozy. Yeah, oh my god, I remember 17. Oh my god. Okay. Well, what's 18? Rope in a tube. Get a screenshot. It's been a minute for me too, Funlocks. I said I would speedrun this book, and that has not come true. Yeah, exactly, Amit. I have been reading chapter 8, but of V&M, but I can't wrap my head around the queue of a circuit. It's really weird. A lot of the math they're doing is kind of like stumping me when it involves Q. Ran away pretty steadily at this until several weeks ago. Oh, okay. A rope is free to slide frictionlessly inside a circular tube that lies flat on a horizontal table. In part A of figure 4.28, the rope moves at a constant speed. In part B, the rope is at rest and you pull on its right end to give it a tangential acceleration. What is the direction of the net force on the rope in each case? No. Quality Q. Or like, the book had like a funny little like sentence about that. Like, where did they talk about it? here somewhere. Nowhere? Excuse me. I want to find the sentence now. Here we go. I thought this like sentence was a funny little like jab at, or like not jab, but like thing. This number q, not to be confused with charge on the capacitor, is said to stand for quality or quality factor. In fact, no one calls it that. We just call it q. Yeah, okay. But yeah, like they do a lot of calculations involving that, and I get completely lost even on the steps there. Do I code? Yes, a little bit. It's not the focus, but me and Zach have done some like coding competitions actually, and we just did one like 2 weeks ago. I usually use Python. I'm not super good with it. I'm interested in learning NumPy, but not interested enough to actually grind at it. Yeah, there. That's the bottom of when we did the last one. It's a good time. I have coded just like for fun on stream too, like not as part of an event, but I usually get kind of bored with it. I love the idea of coding, but actually making a decently big project is just kind of a pain in the ass. Consider creating any simulation. I haven't created a simulation from, well, I've made a very basic simulation from scratch. I worked on code that someone else wrote, and I expanded on it for simulating a routing algorithm in an ad hoc network. And so I expanded on that code a lot. And basically, if you have a bunch of like nodes that can transmit and receive messages, and one of these nodes is your intended, like let's say this is you and this is your recipient, but you don't know where your recipient is, how can you most efficiently blast out your message either in all directions, or like, you know, either to everyone in a radius or only to certain people in a radius? How can you do that in a way that's reliable enough to always reach your recipient while not wasting energy? Was kind of like the thing they were optimizing for. Probably more explanation than you like were asking about, but simple math solver if like to do something you may like. I don't know what that means. Or simple math solver if like to do something you may like. Yeah, I'm not sure. I'm sorry if you could explain that. This is one. Okay, this number 18 doesn't involve calculations. I think part A is relatively straightforward, where it always points radially inward because it's constant velocity. I don't know how exact do we have to be here, because I expect here each piece of the rope has a component going radially inward and a component going tangentially, and the resultant vector is somewhere between those two. but I don't think we have enough information to actually calculate that, like, or like to get an actual angle. I mean, we could attach some variables on here. I wish they would say either do calculations or don't do calculations here. Project for you. Oh, you're suggesting projects for me. I see. I'm sorry. Maybe. There are some things that I'd like to code for the stream that will be useful, and I've been too lazy to do those. But yeah, those are definitely ideas. Thank you. Oh my gosh. SymPy. I haven't heard of SymPy. I assume it's like symbolic math. That sounds kind of cool. Notice me, senpai. I was thinking in my head, it's like, oh, it sounds kind of like simp. Symbolic math? Okay. Wait. Is this a trick question? The rope is at rest, and you pull on its right end to give it a tangential acceleration. In that instant in time, isn't it just tangential? It's going to have a radial component, but right at that instant where you pull it, it's only tangential, right? I feel like I'm being tricked. Or maybe I feel like I had the right answer initially, but now I'm like overthinking it. Or maybe I'm underthinking it. I never know with this book. Oh no, I wasn't showing the right thing. Sorry. I wasn't drawing all that much, to be fair. But I guess I'm saying my answer for part A is radially inward, and part B is just tangential. It's about to have a radially inward component as soon as like you go past time 0. But I think they're asking at time 0, in which case it's only tangential. But again, I don't know. Let's see what the answer is. Number 18. Oh my god, all these Atwoods problems. I need to cover my eyes from the trauma. Oh. Wait, what? Oh no, I got tricked. The net force. I'm looking at the force on each individual piece of rope. Okay, I didn't read the entire answer through for part A, and I didn't see it at all for part B. Okay. I did see the piece where the horizontal components all cancel. It's most clear in the case of each end of the rope are going exactly horizontally, and those are going to cancel. Whereas at the very top, nothing is canceling because it's exactly vertical. And so it just has a net force down. Now, tangentially, I think what I said is true for that end of the rope. It's going straight down. But this end is going straight up. So those cancel. That end is, or like the top, is unopposed, going to the right. And everything else, like this one here, the vertical part will cancel the vertical part over here. But their components to the right are going to cancel, so are going to add. So I'm going to say that's going to the right. And let's see if I got tricked the second time. It's a weird second solution. Give it part B. Okay, right. I did part B right after understanding this was the hardest problem? As soon as I understood it was the entire rope, I feel like I kind of instantly understood what was happening. For me, the hardest problem so far is the one before this. That took me half plus one plus another half, 2 full pages. And the one before that was also really annoying. This one, it just kind of makes sense to me, at least. There's no actual like calculations to really do here. Ooh, the tension in the rope is not constant when it's going in a curve. I guess it has mass, so that's okay. What's the center of mass? Explanation. That one's is still kind of weird to me. Hey, Koshi boy. It's a funny name. This is Problems and Solutions Introductory Mechanics by David Moore. I see your first time chat, so the theme of the stream is I do like math problems that people might have in chat, and if no one has a question at the time, I will choose something to study from. And for the last like 9 months or so, I've been interested in physics. So I've been learning mechanics and electricity and magnetism. And I was just working on a random mechanics problem right there. I do see your first, or since you do seem to be new here, let me shout out that I'm not the one who like streams math. So if you're interested in math streams in general, there's a lot more people who do it than just me. So you don't have to do anything you don't want to do, but I just like to let people know that this niche exists and it's not just me. Hamiltonian mechanics? Oh, I think it's probably a little beyond me. Thank you for the follow by the way. Oh, that's not rude, Raven. I'm thinking like I'm about to wrap things up, to be honest. I was planning to end with that problem. If you have a question though, I'll take a look. Hourly dose of internet. I was just doing a mechanics problem for practice. I did answer your question previously, or like I don't think you were there at the time, but I did explain binomial versus geometric a bit. I typed your... Oh, I didn't type your name in chat. Shoot. Not too long before this, I did talk about geometric versus binomial, though. Do I still have it? Oh, I deleted it. Yeah, I'm sorry. So, oh, hey, Marshmallow. Thank you for the follow. Okay, let's see if let's take a look at what this differential equation is. And see if we can understand it. The phase difference in waves? Okay, I'll do that quickly. For the phase difference between two waves, you need to pick 2 points that are like corresponding. So if you have one wave like that and a second wave like that, you need to find the difference. Like, say I choose any point you want on the first wave, just make it something relatively easy, like a peak. Get the difference between this peak and the next peak on the other wave, and that's the phase difference. So like whatever that distance is there is what you want. You can also do it like a valley and a valley. You can do it with any point you want, but it's easiest with those. 2 points on the same wave. Oh. It's basically the x values minus each other. So like say the phase difference between that value and that value, it's just that like horizontal distance there. That actually that is an angle. That distance is also an angle. It's a weird thing. When you graph things like that, you're saying that the distance is the same thing as an angle. It's kind of like a weird thing with graphing waves. Analytical solution of the phase differential equation, the van der Pol equation. So I guess that's our van der Pol equation there. Doesn't look second order, linear, not constant coefficients though. And it's non-homogeneous. Whoa. Okay, sorry, I'm messing around. So I won't be able to solve this from scratch, but I can see if there is a given solution somewhere. There might not be, Koshi boy, or I don't know. A Hamiltonian H for the system equations. Okay, well I don't know if that helps or not. You know it's bad when Wikipedia doesn't even mention a solution. Oh wait, it is a homogeneous. I was just misreading it. Oh wait. related to RLC circuits in some way? Oh. Instead of resistor, you have a semiconductor. Okay, maybe. Oh, it's not linear. Oh my god, I was getting my variables mixed up, yeah. Oh god. It's been so long since I've done something like this. I feel like by how this discussion is happening, there probably isn't an analytics solution. I'm pretty. I haven't like seen this before though, so. Unless I'm looking at this like a slightly wrong thing, the phase differential equation. Professor thinks there is. I'm not asking AI. They're doing something here. Oh, okay, yeah. I mean, that's just if alpha is much less than 1, you can ignore it. Hmm. Huh. Okay, yeah, I think that this is using techniques that I haven't learned, or if I did learn them, I've forgotten them. It looks like this website claims you can get an approximate solution. The perturbation method. I definitely have heard that. I don't know if I've done it, though. It looks like it's something where you start with a simple case where this parameter that they're calling alpha is very small. You can solve this simpler case here, and then somehow use that to figure out the more general case, to approximate it. Let me look at this one, but yeah, if I don't get anything from this one, I think I need to. I don't know anything. It's probably beyond me. I think this is using more or less the same method, actually. Perturbation method. Yeah, Koshi boy. Kind of unlucky that you have to do them numerically most of the time. All right. Yeah, I'm sorry, Marshmallow. I think this is just a little bit too far beyond me. Um, this paper does claim to have done it. Um, I haven't learned this homotopy perturbation method thing though. Oh yeah, it's right there in chat. Or I do really like differential equations and this type of stuff, but I don't know enough about it. Thank you for the question, and thank you for trying. I hope you can find an answer to it. I'm not even sure if who would be a better person to ask, unfortunately. This is just kind of advanced stuff. Oh, is that like a topology term? Or like, I mean, I wouldn't be surprised if it comes from topology in some way. It's topology has to be helpful for something, I'm sure. How you deform one map onto another? Oh, okay. All right. Unless there's anything else for the good of the order, we might wrap up the stream here. So if we don't have any like final thoughts here, let me know. But we're probably gonna see if there's any friends of the stream who are going. Thanks to everyone who's been here today though. All the new faces. If anyone from Shane's raid is still here, I appreciate you. The Riemann hypothesis real quick. Yeah, let me get right on that. So another shout out to Shane because he's awesome. He has an awesome history stream, and he rated me earlier. Let me cut off the YouTube stream. If you're here on YouTube, thanks for being here. And bye YouTube.